So now in recent videos we used the P-channel enhancement mode MOSFET. I got the BS250 right there, and the N-channel enhancement mode MOSFET. We made switches with them, and now we're going to combine them. And where their drains connect together, we have an output, and the output can be either high or low. And it is actually the opposite of what the signal is. So it can either push or pull current, but since the output is the opposite of what the input is, we can call that an inverter. So that's not a power inverter where you take a DC voltage and make an alternating current. It's a signal inverter. So whatever's coming in, the opposite is going out. And zooming in, you can see that we got the jumper to the positive supply. Right now the blue LED is lit. That's the positive supply over there, bringing the resistor, bringing current, and so it's headed to ground right there. So the output's connected to ground. That's the only way the blue LED could be lit up. Now this will pick up stray voltages in the air just floating right here. So if that's a problem, you'd have to add like a pull up or pull down resistor or something. Digital outputs, which you'd most likely be using right here, they do not float. They're either high or low, so you don't have to worry about that. But in any case, there you can see, now we got the jumper to the negative supply right there. The red LED is lit up, and you can see that its resistor is to the negative supply right there. So you know that we got positive coming along and lighting up the red LED. So negative input, we got a positive output, and positive input, we have a negative input, as you can see right there. And now we move over to the schematic that I drew a while ago. And so they're basically in series right there with their gates tied together. The P-channel enhancement mode MOSFET and the N-channel enhancement mode MOSFET. Look at the arrows right there. You can see that they're heading from positive to negative. These are not universal symbols though. That's my little note down there. There's all kinds of symbols that could be used for MOSFETs. Hopefully there'll be a part number. Then you'll know for sure what it is. You can just Google that. We tie the gates together so they're both getting the same voltage right there. And when you go to the positive supply, what that does is it turns the N-channel enhancement mode MOSFET on, while it turns the P-channel enhancement mode MOSFET off right there. And because it's positive, so we got positive of the gate makes the channel negative right there, which is how the N-channel conducts, whereas it's how the P-channel turns off. And so when the N-channel is on, there you can see we got the blue LED lit up. Our output is low right there when the input's high. So now we flip the switch over there. Imagine that. We got negative. So now negative coming to the gate makes the channel positive, which makes the P-channel conduct. When the N-channel is positive, it turns off. And so we got conduction there, and the red LED lights up. I used a 1000 ohm resistor because the blue LED is brighter than the red LED. So we're dropping the current by a lot, and it's making the LEDs about the same brightness, 220 ohm right there. And we can look at the pin layout. And so with the 2N7000, we got source, gate, drain, which means I turned this to the right, flat side to the right, so that the source would be at the bottom, as you can see right here. And then the middle pin right there, we got that little jumper going up 2 spots to the middle pin of the P-channel MOSFET right there, BS250, and our jumper as well. Hopefully you can see that. And then where the 2 jumpers are connected is the drain right there. So BS250 drain. So this is the front, the little flat side. Drain is to the left, gate, source. So if we want the drain at the bottom, we also turn it to the right. So it will be the little side to the right, as you can see right there. Pretty easy to wire. Drains tied together, and they go to the jumper there. And then so its source is up there going to the positive supply. And yeah, that is really about it for this push-pull. It makes a good connection to the positive supply and the negative supply. We've looked at other integrated circuits that fall quite a bit short of usually the positive supply. A lot of them even fall short of the negative supply. And so if you have a problem with an output of an integrated circuit connecting to the supply voltages, you can just feed it to a couple of these MOSFET transistors right here, and you should have a pretty good output to whatever the current limits are of these two. And so I think the 2N7000, it's a maximum current of 200 milliamps if I remember right. So I would keep it below 100 milliamps. But in any case, you know, it can pass a fair amount of current. I'm assuming the BS250 is about the same. Again, that's stuff you'd look up on a data sheet, and I didn't spend hours preparing for this video. This is an old diagram that I thought was a good time to review right now. So that's really about it. Hope you enjoyed. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.